Ladies and gentlemen, I'd like to introduce Pamela Harrison, who will be giving a wonderful presentation on the Intel Graphics Performance Analyzer. Pamela, take it away.
All right. Hello. Welcome, folks. So, as Eric said, I am Pamela Harrison. I'm a software technical consulting engineer for Intel Graphics Performance Analyzers. That means I enable customers to help real-time rendering by helping them use GPA to find performance bottlenecks. So, I'm going to give you a tool to help get your game from awesome to the next level by helping your performance. By far, most Intel GPA customers are game developers. Intel GPA helps with hotspot analysis, multi-frame analysis, system-level profiling, shader profiling, and more. There's a lot of information packed into the next 40 to 50 minutes. It will be kind of a whirlwind, but I'll point you to more information so you can see the details again, and this video will be available later. So, I want your key takeaways from this, even though it's a whirlwind, there's a lot of information, is what can Intel GPA do to help you? And what's the easiest way to start using the tool set? Let's dive in. What is Intel GPA? Intel Graphics Performance Analyzers is a tool set designed to help game developers and others with real-time rendering applications quickly and easily analyze and optimize their games. It allows you to capture and visualize gameplay data so that you can see where your bottlenecks are. A possible workflow is to first use our system analyzer, which you can see there on the left, because you can watch the real-time data as you play your game. Then, if you see in there some area where the metrics and data is not quite what you want, then you can narrow down the area you're looking at by capturing a trace, several seconds, say 5 seconds, 7 seconds. The smaller the capture file, the faster it will open. So capture several seconds of gameplay and then analyze that in our graphics trace analyzer, which you see there on the right. And then third, after narrowing it down and seeing, oh, there's this frame or this area where something looks wonky, and I want to drill down and see the detailed information. So then you capture a frame or multiple frames in that area, and you can see the data in Graphics Frame Analyzer. So these are our main three tools. These are the analyzers that you use when you're using GPA. No questions?
I don't think there are any questions at this time. One thing I think I'm going to mention just briefly, I didn't think I heard you say it, is if anyone didn't already know, the Intel Graphics Performance Analyzer is a free tool.
Yes, thank you. Okay, so I mentioned our three analysis tools: System Analyzer, Graphics Trace Analyzer, and Graphics Frame Analyzer. I didn't say Graphics Monitor because Graphics Monitor in itself is not an analysis tool, but this is the hub. It's the central location where you can start your games and make captures and go to a trace. Okay, so capturing a trace, you can either hit the start down here or you can go up to whichever game you want. I currently have, you can see down here on the left, I currently have the GPA sample selected, but I could select a different one and this would populate. With the trace mode selected, so it will open the capture window with the game playing. Oh, there it is, and I will drag it over to my screen. Here, you can start the boulders or not. It's going to capture the information. And so it doesn't capture a trace until I tell it to, and you can see here, Control-Shift-T captures a trace. And it's starting to capture a trace. It's in progress. I believe I have it set to 5 seconds. Okay, now it's completed. I could capture another trace now. I can play the game some more and then capture another trace. All the traces I capture now will be 5 seconds because that's what I have it set to, but that can be changed. Okay, I'm going to close this window, and this is a trace. So I'm going to open the trace I just captured. That opens in yet another window. So I bring that over here. So it's opening, and you can tell because it says opening right here, and it's filling in the data. So let me make that bigger. Okay, so there's a lot of stuff here that may not look like much of anything until you zoom in, and then you can see stuff.
Wow.
Okay. That is the correct response.
I feel like that's like when you see these, electron microscopes, it's like here's a single salt atom. Wow.
So you can zoom in as much as you want. We have lots of features you can select. If you look down here on the bottom, there's this bottom left, selected items. There's nothing to show right now, so nothing shows. But if I make a selection, then suddenly these two other tabs showed packages and regions. So I can look at packages. I can say I want to see more information about this render package. Then this window populates. And then if I want to see more information about one of these bits, I click on it and I get the really low level stuff. So you can look at all kinds of stuff. Now there's more tabs that aren't showing because I haven't selected metrics, because the metrics are way down here. So what I'm going to do is, if I right click and select an area, this will select everything, all the timeline elements, all the way from the top to the bottom. So now I have these two other tabs, markers and metrics. So I can look at the metrics, I can look in detail, but we have videos, we have quick tip videos, deep dive videos. Again, you can look at regions, you can look at packages. Now, if I unclick, so click anywhere else, that information goes away because I haven't selected anything. I could even select a single item signal.
Emily, can you scroll up a little bit and just explain a little bit on the left? Left columns that you had, I saw that you had like CPUs in there and then a bunch of other rows. And you want to break that down a little bit as to all the examinations that we're doing here?
Yeah, so you can see my my 4 CPU cores and what they're doing. I can zoom in to see how the load is divided. You can see it's divided evenly. We helped a customer once, and they had everything running on one of their cores, and then it switched everything to another core, and it kept doing that, and they didn't realize why they weren't getting better results. But looking at this, it was so obvious. So you can see what's happening on each of the cores. You can see here in this GPU 0, it's GPU 0. I only have one GPU on this machine, but you can look at multiple GPUs and integrated and a discrete GPU simultaneously. So we label them 0 and 1 if you have two GPUs you're looking at. So here's a GPU. So let me scroll out and see this area right here. Nothing's happening on the GPU. So to make things better, maybe we could offload something that's happening on one of the CPU cores onto the GPU so that the GPU is not idle right here. So that's one of the things that you can easily see in Trace Analyzer. Okay, so you've got the CPU cores, the GPU, the main thread of the application, and then you have the lower level threads, and then there are metrics. So you can look at the metrics. Let me go farther on where it's more interesting, or zoom out so it's This doesn't look very interesting there. So there's more metric stuff. You can hover over it and see different information. And so all kinds of metrics, and you can turn them on and off over here on the right. So this is really handy. Say I don't want the CPU stuff right now, so I can turn that off. If I want it back, I can turn it on. It's just, clicking on it. And then
one important observation I'm making so far is that while we do call it the graphics performance analyzer, it's actually analyzing effectively the whole system. As you mentioned, you can see if you have a multi-threaded CPU and it's not actually a multi-threaded application, then that could be a reason for some of your slowness in your application or your game. And so it's not just about looking at what the GPU is doing, it's looking at the whole system.
That's true. I haven't gotten to our frame analyzer yet. That is our main tool where you can really drill down into graphics. So, but before you drill down into the GPU to see what your bottlenecks are, if you fix all your GPU bottlenecks by using frame analyzer first, and then you find out it was your CPU that was a bottleneck, then maybe you spent a lot of time where you could have spent time making it faster, easier, looking at other things. So we usually start, like I said, with System Analyzer to just play the game and watch it and see how it goes, see if there's any great big spikes. And then when we see a spike, we put it in here in Trace Analyzer, and then you can see, yeah, like you said, Eric, the differences between, well, when is a CPU busy, when is a GPU busy, is it all spread out nicely? Go back here and I can capture a frame or a stream. Let's capture a stream. You can go into options here. Here's trace options in this tab. And I can go to triggers, where I can say, well, I want a frame capture to happen when the GPU busy reaches over 95%, or other criteria. You can add all kinds of criteria in here. So you can set.
Is there a frames per second criteria?
Yes. Right, Eugene?
Yeah, hello.
Hi.
Yeah. You can set a trigger for frames per second, right?
Yes, sure. Just clear everything, type, start typing with quotes, and you should get hints which metrics are available.
Wow.
Okay, so yeah, there's a few.
Some of them are disabled depending on a particular device capabilities, depending on driver capabilities, or enabled metric collection mode. So there are many criteria when metric is available or not.
Capturing a stream, let's start that.
So in this screen here, the icons at the top are actually different games that you might have on your computer that you want to test.
Yeah, and you can add any others. You can, with these, you can browse to a different game in a different place. So you can open anything you have.
Nice.
Okay, so the stream recording's on. You can set it to not start when the game starts so that you can capture it later. We call that deferred capture. We added that just recently in our last release. It used to always start at the beginning, and if people wanted to capture 10 minutes in, they had to capture so many frames that it took a long time to open the captures. So this is my new capture. So I open that, and Frame Analyzer will open in multi-frame view because I captured a stream. Okay. So like before, it's opening. So I'm waiting.
So the observation I'm making so far is that the The nice thing about the overlay is that our folks can be working on their alpha or whatever version, and they can just sort of play the game, right, with the overlay on, and they can watch the frames per second, and it's okay, everything's good, and then they get to the point where the boss emerges from the egg or whatever, and then suddenly it goes to 12 frames per second. Like, oh, this is a problem area, and then it allows them to figure out, okay, when for some reason my boss emerging from an egg is swamping my system, and then you can go into capture that particular stream and then go into the deeper level and figure out, okay, well, it's because for some reason when the egg emerges, it all goes to single threaded instead of multi-threaded or whatever. And you can start to dive in deeper into the data and figure out why you're getting a slowdown at this part. So I think that's very handy.
Exactly. Good.
Hey, Tim from Montech Labs. How are you guys doing?
Good. How are you?
Good. Yeah. So the way that, I spent a little more than 10 years as a tech artist. The way that we tended to go ahead and do any sort of QA testing is that we would do a recording in the background. One of the things that you had alluded to was being able to do this on a second machine. So being able to set up maybe one machine that's the record machine for every one of the QA testers that's out there, and then be able to go ahead and do that stack trace. Is that an easy to set up process, or is that something that is kind of outside of the scheme of how this ecosystem works?
Remotely, you can open collected frame files and collected stream files. So first thing that you need to do is to run graphics monitor on remote machine, start an application, capture stream file or frame file from it. It will be captured on target machine. Then you can switch back to your host machine, run frame analyzer there, and specify host name of target machine, and then open a stream or frame file on that machine. So in this case, frame analyzer will be on a host, but frame and stream will be replayed on a target machine.
Gotcha. So, I mean, an easy workflow would be, a single location. Maybe the triggers are run on that machine as well. That way, you can have all of your QA people. They're all just going through and they're playing the game as normal and everything like that. And then when a trigger hits, then you get, your 5 seconds record that's happening. It goes back to a central area. One of the big things that's, a lot of people, when they're doing QA, they may perceptually notice a change, but if they don't, it may not be,
I think we lost
time on the UI pop up. I cut out. Oh, okay. So I guess my big comment is, you could end up having that separated, where somebody is, your QA team is actually just running, and then, you would actually kick it back to a main machine. Maybe QA goes, hey, this area is running slow. That way they can do a perceptual kind of run, instead of actually going through and going, well, this is below frame rate. It may not be an actual issue. If you're below frame rate and say it's a UI pop-up, does anybody really care? No, not really. But if it's like a big boss, like Eric was talking about, where it pops out, that may be a good one. Very interesting use case on that. I'd love to see that further in action. It's awesome.
Okay, thank you for the question, and thank you, Eugene. Okay.
So first thing that you need to do is to select DirectX Context 1, purple one on left panel. Yeah, and select a frame from it, any frame.
So I can look at this and see, oh, this little bit is taking a really long time. So I clicked on it, and then it highlights, it's this draw call right here, you can see on the left. And I can look at different views of it and get different information. I can see over here the call stack, and the red ones are the bottlenecks. So if I do something to fix this, then it might have a different bottleneck to look at. The red is the the most time consuming, and then orange is next. And you can look at the pipeline, you can look at current selection, and you can see all this information. And then you can compare this information to, which is this draw call we're looking at, to the full frame information. So it can be helpful to look at one draw call and then another draw call and see, well, oh, this one draw call is taking a long time in this area. Maybe I had to drill down into that piece. So, tiny demo, that's what I just did. So here's the trace analyzer view. And it's right here showing an arrow. So we've just added these in the last 2 releases, our arrows, so we can see dependencies, which is really, really helpful. And have to throw in the multi-platform, Linux and Windows. Excuse me, we support DirectX and Vulkan, Unreal and Unity. So, so we're very flexible. System Analyzer. So I showed you System Analyzer. If you're looking at System Analyzer, you can see the real-time data as your game is playing and it's flowing by. You can actually take any one of these rows and you can superimpose it over another row so you can compare directly. And you can actually do that multiple times. You can say, I want to stack these 5 and compare them. They're different colors. So you can stack as many as you want. And then there's pause mode. So if it's running by and you say, oh, I want to look at the last 2 minutes of my run, there's this pause mode button right here. And we have several quick tip videos, and there's it's a 1.5 minutes, I think, video that tells you how to use pause mode. So you can look at the last 2 minutes or 5 minutes or however many minutes you'd like. System Analyzer, then Graphics Monitor. I showed you this is our hub. It's the control center. It's where you start your games from and then capture your traces, change your options for what you want to collect, how long you want to collect. And then Trace Analyzer we looked at, and that's where you can see the CPU cores, the GPUs, the syncing, which, you know, like I said, we just in our last 2 releases added the syncing. So you can click on anything, and then it will show the arrow if there's a dependency somewhere. So that's Trace Analyzer. Okay, so the highlights of Frame Analyzer, you can do hotspots analysis. You can analyze sets of events. You can we capture, as you've seen, we capture a lot of data, and so you can group data. You can look at specific draw calls in a frame. You can do experiments. Experiments are really helpful because you can click on an experiment to change a particular thing, and then see visually how that changed your code. So, sorry, not your code. It won't change your code. How that changes the visual, so that you'll know if you want to go change your code to do that thing. Okay, so I just showed you the multi-frame view, the stream view where you can select a frame in Frame Analyzer, and then the frame view where you can you can look at a particular frame and lots of information about it. Okay, so now I'm getting to my sample use case. So Intel works with gaming companies sometimes to help them optimize for Intel architecture, because sometimes people don't analyze on different platforms. So we'll take a game and try it out on our platform and then talk to the gaming company and say, hey, we're seeing some issues. Can we analyze your game? And so then sometimes we find how they can make it faster on even a platform with just an integrated GPU. So starting out, use GPA to find the issues, the big issues, the expensive calls, so that then you can dive in. So GPA helps you do that. In this particular situation with Gears Tactics, we added VRS, and then we used experiments to override settings so we could see, again, visually, did that change it? Did it make it better? And so that's really handy because you're not changing your code, but you can see if there's something maybe you should change. And then we drilled down to find that there was use of this R11G11B10 float. Well, if you're familiar with IEEE 754, you know there are optional types, and most of those optional types are not implemented in most hardware. So Intel hardware doesn't implement this optional type. And so whenever it's used, then sometimes there's visual corruption. So we were able to use GPA to drill down to that. And I am currently working on an article to go through the details of how you would drill down. So then, what's new? What's upcoming? We have a release coming out next month, our Q1 release. And so I'll talk a little bit about that if there's time. But first, I have brought Robert Kawiak. I hope I pronounced that right. He is going to do,
yeah.
Okay. He wrote a plugin. He's at Intel, and he wrote a plugin because he uses GPA to analyze games. He wrote a plugin for Unreal Engine. So I'm going to let him talk about that and demo that. So
Okay,
Robert,
yeah.
can you just take control?
Yes, let me do that, and I'll be sharing my screen. So I'm Robert Kawiak. I work at Intel as a graphics engineer, and I focus a lot on working on game engines and making sure they work correctly with Intel, their performance. So GPA is a good tool to dive into what the engine does and to look for performance bottlenecks. And Unreal is, one of the most popular engines, and I decided to integrate GPA into Unreal to make it really easy and seamless when you want to capture a stream. So I hope you can see my screen. Yep.
Yes.
Yep. Okay. So first of all, this is a plugin that will be open source. It's free, and it will soon be released on Intel's GitHub page very soon. Once you have the plugin, you can just copy it into the engine, and I'll show you that if you want to enable it in the engine, this is the typical view that you have in Unreal for those that are familiar with it. You just have to go to the plugin sections, type in GPA, and here there's a section where you can just enable it. If once you click on enable, it will restart the editor automatically. And when it comes up again, you'll see this icon. So this is something that's new. This is something that's enabled if you have the icon, the plugin running. And if you now just want to capture a scene, you don't have to use the graphics monitor to run the application with some parameters. You just click on it once, and you'll see that there will be information that we're capturing a stream. So we can go around the scene, do whatever operations we want, and we can just stop it with the same click. And that would open the stream in graphics monitor. You can open it and do all of the analysis that Pamela was showing. You have the frame view. You can select the frame that's a bit longer, and maybe I can just open it. So it's opening in the background. And that's one way to capture. You can also do it within the game. So in Unreal, if you run the editor, there are some things that are different than if you're running in game mode. So you can, let's say, we can start a game mode, and within the game mode you have the console, where again you can start. This is a console command line where you can start the capture at any given point. Do the operations that you want. All right, and stop it. And again, you'll see this information pop up that the capture has started and stopped, and you can do analysis later. And if you can see, we have a new stream that has been captured. And during the session, you can, if you're working on some project, you can do it multiple times. So look at some problematic section, capture it, do some changes, do another capture, and then later on, you can move it to this stage and do the analysis. It's still
when doing the capture, does it? When doing the capture, does it segment out the engine overhead?
I mean, the thing that it does, it captures all of the 3D API calls that the engine is doing. If you're talking about overhead, it will capture the GPU calls that the engine is using, and some CPU operations won't be visible in the capture if you're looking at this view. So this will focus mostly on what is sent to the GPU and preparing the work that is sent to the GPU. If you have some kind of work that's related to AI, physics, these kind of things that are not sent at any point to the GPU, in this stream view, they're not visible. So Pamela was showing this trace view that showed the CPU queues and the GPU queues. It will be visible there, but this stream capture that I'm using here is most useful if you want to really dig into what the GPU is doing, what are the commands sent to the GPU. And if you, for example,
in typical, it does end up separating it out. For obviously the GPU view, yeah, of course, it's not going to show too much of the overhead because there's not really that much overhead that goes to the GPU for that. But if you did a full analyzation of it, you would also be able to see in the CPU the segmented out section that says that it's the engine, or is it still pretty deep in there?
I mean, you'll see all of it. So that's why it's useful to use these tools, because you can really see what the engine is actually doing. There's no hidden information. You can analyze all of the work that the engine is doing. So, like, for example, you can see that here's some interesting part of work where you send something to the engine, and you see what are the buffers used for this section, what are the API calls used at this point. You can look at the shaders. So this is a disassembly of the shader with the resources that are used. And this is the kind of typical things you would do if you want to analyze these kind of peaks in the time of a rendering call and see what's happening there. So yeah, and that's about all there is to it. I mean, that's the whole idea, for it to be simple and to automate a task that normally it would be quite cumbersome to go into the engine, go out of the engine. Here you can have a session that's running a couple hours and just selectively choose what you want to analyze.
But it looks really cool. We had a little bit of a chat window going on the side, and we've got several Unreal users in the audience, and they think that the idea of being able to have this directly in the editor is going to be a great assistance for them. So great job.
Cool. Yeah, and I mean, it really improves the quality of life when you're using the editor, and it will be open source. And also, if anyone wants to add features, you can contact me, or you can contact me on the GitHub page once it's up there, and we can expand the plugin to have more features.
That's great.
Okay, thank you, Robert. Okay, we just have a couple minutes left, so let me cruise through the rest of this. So you've seen multi-frame analysis. We have completed our implementation that we will release, like I said, next month, with more complete implementation of multi-frame.
And to be clear, when we're saying next month, we mean March of 2021.
Correct. Yes, thank you for clarifying. So that will be more complete for DirectX 12 especially. And we will have full support for syncing. So you saw some syncing, the arrows, you highlight one part of one call or one part of a call, and it will show you, what that calls and in what queue it is. But we have CPU to CPU, CPU to GPU, GPU to GPU, and GPU to CPU. We have all that currently, but in our March 2021 release, it will be fully implemented with the Win32 API as well. Framework is our backend, but we've made it available as a separate download, separate from the GUI tools that I just showed you. And so you can do things on the command line. So you can use it in your continuous integration cycle. You can use it, you can write scripts to automate testing for things you do. So we're on resources, we're at questions, and we're at the end of the hours.
I think this is really good. This was a good summary.
Multiple
I
times.
think for me, one of the things is this is a free tool, right? So you lose nothing by trying it. And I think from what I've seen, there's a great potential for all kinds of benefits to not just game developers, but any app developer. If you're doing something visual or something like that, you can watch the deep details of the information, zoom in on incredible nuances, and see where everything's going on. And if nothing else, they can at least run it in the overlay mode and see what their frames per second are. If they don't want to build that into the game, they want to build a benchmark, they can just use GPA, make sure that they're getting a good 30 or 60 frames per second. And then if they do get to a place where it's like, hey, this is not working, they can be like, well, now we know why. It's this area here, and it's this call. So it should be of great benefit. Before we let Pamela go, any other questions? You can either take yourselves off mute or type them in the chat window. So Pamela, Eugene, Robert, I really appreciate you coming in today. This has been great, and we'll look forward to hearing more from you guys in the future.
All right. Thanks for setting this up, Eric.
Perfect. Thanks, guys. Have a great rest of your day.
Yeah,
Thank
thanks.
you.
Thanks. Bye.
Bye.
Bye.